Welcome to investigation 2.3. In this investigation we did treetop fun, so it was talking about zip lines and bungee things and rope bridges and that sort of thing. In this we were looking for equations for linear functions, and our focus question was, what strategies do you use in writing equations for linear functions? So we were thinking very deeply about what we truly need. And if we think about our linear functions, we are looking at these sort of equations. Y is equal to mx plus b, where m is slope and b is y-intercept. So looking at those two ideas, we are creating equations given various scenarios. So let's look at a couple of scenarios. Here we go. Write an equation using the tables below. So let's look at this first table. We have y and x, and this y, or this x, let's see how it changes. Remember, we're looking at how the x changes, how the independent variable changes in comparison to the dependent variable. So the independent variable in this situation, it looks like it goes plus 3, plus 3, plus 4. So I'm not so sure if it's even linear as of right now. It all depends on what's happening on the y. 2 to 8, we need to add 6. 8 to 14, we need to add 6 again, and 14 to 22, we need to add 8. So maybe it's actually linear because the y, this last one, changed a similar amount to the x above it. So we're looking at rise. Oops, I'm going to do that in a different color. We're going to look at rise over run. So rise versus run. I should write rise in green, not paying attention today. All right, so we have 6 over 3 versus 8 over 4. So let's do a little bit of math. 6 over 3 becomes 2 over 1, which is equal to 2. That's good. 8 over 4 is equal to 2 over 1, which is also equal to 2. So there is our slope. I'm going to write that there, slope. There's our slope. And also for our x, for our y-intercept, we need to find where x is equal to 0. And so when x is equal to 0, our corresponding y value is 2. So now we can write an equation. Our equation format, y equals mx, that's not an x, that's a star, x plus b. So our slope is that m, and that b is our y-intercept. We've been talking about this for a while. Slope is our m, and in this case our slope is 2. We're going to add our x in there, and now we need to add our b, which is also a 2. So there is our final equation for this particular table. Y is equal to 2x plus 2. So now let's do the same thing with this next one. Let's look at how the x changes, so how the independent variable changes in terms of the dependent variable. It looks like this independent variable is progressing upwards by 2. This dependent variable is increasing by 3 each time. So looking at that, we have our rise over our run. So we have a 3 over 2, which is equal to 1.5. But we could also keep it as 3 over 2 because that shows us our rise over run. Now looking for our y-intercept. I don't see a place where x is equal to 0, but I do see how our table is increasing by 2, or we could say it's decreasing by 2. If we are going backwards. So let's subtract 2 from this one, or from the x-intercepts, or from the x-axis, and see where we get. If I were to take away 2 there, that means I need to go on that same sort of pattern. I need to subtract 3 from 5, so we get a 2. Our y-intercept is also equal to, very similar to our previous equation. So let's write this equation out. We have y is equal to our slope, which is 1.5, x plus our y-intercept of 2. So there we go. we can either write y is equal to 1.5x plus 2, or we could write it also as y is equal to 3 over 2x plus 2. Either way, either one works. So that's how we can write equations using tables. Now let's write an equation using a word problem or a description. Dakota lives 1,500 meters from school. She leaves for school walking at a speed of 60 meters per minute. Write an equation for her distance d in meters from school after she walks for t minutes. So I underlined some things as I was reading through that. I underlined the numbers, and now I'm going to box them up. And I also underlined the variables. The variables stand for numbers for very particular situations. So now let's think about this problem. Let's think about, would this problem become a decreasing graph? Would it slowly decrease, or would it slowly increase? We're looking at distance, and it looks like she's going to school. So I'm thinking that 1,500 meters should slowly decrease. So something in here, either this meters from school or her walking, needs to be negative because we're going to decrease. So let's look at distance. Distance is rarely negative. It's something that's typically positive because you're usually not a negative distance away from something. So because of that, I'm actually going to put my negative, instead of it being on this 1,500 meters, I'm going to put a negative on this 60. So I'm going to now add in these numbers. We have negative 60, and I'm also going to put in 1,500. Okay. Now, let's think about what these various things say. Distance, that's in meters. As well, we have 1,500, which is also in meters. However, this 60 is in meters per second. That tells me that I'm going to need to multiply by the number of seconds. So I'm going to add in my t right next to that d and add 1,500 to that. I'm going to put this in blue. Add 1,500 to that. Because this d and the t, the distance, depends on time, and since we have negative 60 meters per second, that's how much her distance is decreasing every second, we need to pay close attention to how much time that takes. So there is my final equation. D is equal to negative 60t plus 1,500. Now our very last situation, we need to write an equation using the graph below. So I got this equation from a problem in our book. I believe it's problem number 27. And I paid attention to these top two parts of the table. This part right here. Essentially the demand of corn versus its price. I did not pay attention to the supply at all, so we can just cross that out. That part does not matter. So here's my graph. If you look at my graph, it looks like I paid attention to this first point of data, or bit of data, and this last bit of data to create my line. So looking at that, I need to pay attention now to creating slope and my y-intercept. So essentially what I need to do is I need to find how this table, or how this line is increasing based on my prediction, and how we can make this table work to our advantage based on that prediction. So let's first look at the slope. Slope is rise over run. It is our dependent variable versus our independent variable. So our dependent variable in this case is the demand, or the number of dozens of ears of corn. So I'm going to look at the change in the rise, which is 200 minus 60. So that is literally this corn versus this corn situation. So we have this point versus this point. We're looking at its rise. How do these two things change in comparison to each other? And then we're also going to look at the run, how they change dollar-wise in comparison to each other. So if we look at that, we have $3.50 versus 1. $3.50 minus $1. So let's do a little bit of math. 200 minus 60 is 140. 350 minus $1 is equal to 250. So how many times does $2.50 go into 14? And if we did a little bit of math, that ends up being 56 times for $1. 56 times for $1 goes in. So that means if we were looking at this particular table, it looks like we have half dollars here. We could also say it's 28 per every 50 cents. This is the slope that we're going to put into our equation. However, this is the slope this version of slope is going to help us find our y-intercept. So let's look. We have y is equal to mx plus b. We have our slope of 56 over 1, so we can rewrite this equation now as y is equal to 56 over 1 x plus b. And now if we want to, we can work backwards a little ways. We can say, okay, if at 201, or if at 200 ears of corn the cost was $1, we can now say, well, 200 plus 28 ears gets us 228, which is our cost at 50 cents. So we're working backwards. So we're at 228. We could then say 228 plus 28 equals 256, which 256 ears of corn would be the cost at $0, which we know is impossible. However, it's going to be super helpful for us to know that because we need to create an equation. So we now have our y-intercept. So we can say y is equal to 56 over 1 x plus 256. Now we can do one more thing to actually create that y-intercept if you didn't want to work backwards and play around with slope in that way. We could actually look at some of our points and we can plug that into the equation. We have y is equal to 56 over 1 x plus b. Let's look at one of these 2 points. We had one point that was $1 is equal to 200 ears of corn. So essentially each ear or dozen of corn would cost $1. So let's put in that information into our table. Here is our y and here is our x. So for y we're going to say 200 is equal to 56 over 1 times 1. And then we have plus b. I actually just realized that I made the wrong equation, and it's not that far wrong. We just need to pay attention here. So one thing that's super important, and this is a great learning point for right now, is it's important to pay attention to making sure everything's in the right place. We have 200 minus 60, which is 200 right here, minus 60 right there. But then if you look at our dollars, we have flip-flopped them, or I have flip-flopped them. This should be $1 minus $3.50, meaning that not a lot has changed here except that there should be a negative sign that follows us through to each part. So our equation should be negative slope, which makes sense given our line is negative, or it's decreasing. So that's something super important to pay attention to. All right, so now given that scenario and the fact that I was completely silly, let's add in a negative to our slope. So we have 200 is equal to negative 56 over 1 times 1, which equals negative 56, plus b. Let's now add 56 to both sides of our equation. So we end up with 256 is equal to our y-intercept, which is b. So our final equation is the exact same one that we see there. Y is equal to negative 56x plus 256. I hope this all made sense to you. If you have any questions, especially on this last situation when you have to write an equation using a graph, make sure you ask questions. It's very important when you create your graph or when you look at a graph that you pay attention to both the y-intercept and the slope. I hope this helps, and again, as always, ask questions. Thanks for watching, and I'll talk to you later. Bye.